Hey guys, I wanted to show you how to construct a box plot by hand that does have outliers. So I took some data from one of your homework problems. You had a problem where the study wanted to compare the calorie content and the sodium content of three different types of hot dogs: beef, meat, and poultry hot dogs. So I basically took some of that data instead of analyzing, all six box plots, I basically just took some of the data and actually modified it slightly. Okay, so what I did was on my calculator, I took the calorie content from the 17 meat hot dogs and the calorie content from the 17 poultry hot dogs, and I just created two lists. So to create the lists, you just go stat edit, then you just enter in the data. So my L1 here, my list one, is the calorie content of the meat hot dogs, but I modified it because on the 17th sample, what I did was, instead of, I think it had a value of like 195, I changed it to 250 just to show you what outliers look like. Okay. And by changing this last max value to 250, it's not going to impact the Q1, Q3, or the median. Okay. Now, this second list is just the calorie content of poultry hot dogs. And for right now, I'm not going to use that. I'll use that later when I'm comparing the two box plots. Okay, but what I wanted to show you is how to make a box plot by hand, to construct a box plot by hand of this list, which is the calorie content of meat hot dogs. Okay, so the first thing you have to do is you have to really, if you're doing this by hand, you want to order your data in ascending order. And a really cool thing that I learned from one of your awesome colleagues, I never knew this before, was that when you have a list of data, you can actually sort that list very easily just by going stat, and then instead of pressing edit, which means change the list or add to the list or make changes, edit the list, go to sort A. Sort A stands for ascending, D stands for descending. So go ahead and do sort A. And then in your argument, just put which list you want to sort in ascending order. So I'm going to sort my list one. So second L1, the blue little things above here are your second functions. So, and then you don't even have to close the parentheses. I'm kind of lazy. I'm just going to press enter, and it gives you a dialog saying done. So it sorted it in ascending order. So now when you go to stat edit, it's put it in ascending order. So I've just copied the data points in ascending order right here. And let's go ahead and create the box plot. So to create the box plot, we want to first find the median. So some of your teachers in maybe elementary math or earlier math classes taught you this little trick, which one of my students taught me. You can just go like this, boom, boom, boom. I actually get confused when I do this, but like that, and there's my median. You could see that visually this gets, for me, I'm an auditory learner, as you can tell, because I talk so much. So visually, those kind of little visual tricks mess me up, but they might help you. For me, what I do is I know that there's 17 observations. So I just look for the middle observation, which 8 are going to be below, 8 are going to be above. So I look for the 8 plus 1. I look for the ninth observation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my ninth observation. Just double check. 1, 2, 3, 4, 5, 6, 7, 8. So 8 observations in the lower half, 8 observations in the higher half. That's my median. So in my lower half, not including the median, I'm going to just throw that out. Okay, so my lower half has 8 observations. Let's find the median of my lower half. So 1, 2, 3, 4. So my median of my lower half is my Q1. So it's going to go right there, Q1, and it's the average of these two middle observations. So it's going to be 138.5 calories. Okay, I do the same thing for my upper half. Okay, 1, 2, 3, 4. My Q3 is going to be 180.5. Okay, so now I have my Q1, my Q3, my median, and I have my max and my min. So that's my 5-number summary. Okay, so how do I now construct a box plot from this? So now what I'm going to do is simply just draw a number line. Okay, and I'm going to make my number line go, something like this. And I could go by fives, but I think I'm just going to go like by tens. So I'm going to start off with 70. And I'm going to go 10, 80, 90. So that's 100, 110, 120, 30, 140, 150. And you can see I'm just eyeballing this. 60, 70, 80, 90, 200. You could use like a measuring tool if you want, but you don't have to. 10, 20, 30, 40, 50. Okay, and why? Because this is just a sketch. This is not to scale. This is not like, a perfect drawing. This is just a sketch of a box plot. Okay. All right, so that makes Q1, Q3, and median. That actually makes the box. Okay, so Q1 is at 138.5. So that's 10, 20, 30, 40. So it's pretty close to 140. So there is my Q1. My Q3 is a little bit higher than 150, a little bit greater than 150. So 155 would be there. So a little bit less than that. So I don't know, something like that. Then my Q3 is at 180.5. So 50, 60, 70, 80. So just slightly higher than 180. Okay, then that is the box portion of my box plot. And I know that some of you are really upset by this because it's not nearly as neat as your work. Your work is impressively neat and tidy. You guys are doing great work. Sorry, Mr. Lee doesn't have those, skills that you guys have. But anyways, that is my sketch. So there's my box. So now how do I calculate where my outliers are, my high outliers and my low outliers? I have to calculate what are called the fences. So before I calculate the fences, I'm going to look at, well, what is my IQR? My IQR is how spread out is this middle 50%? Okay, because that box represents the middle 50% of all of my data. So how spread out is it? What is the range of my middle 50%? Okay, and you know that range is just max minus min. So my range is just, in this case, my max is Q3 minus Q1. So that is equal to 180.5 minus 138.5, which is, I believe, 42. So that's my IQR. So now what I want to figure out is, what is 1.5 times my IQR? Well, 1.5 times 42, if I add 21 to that, that's just going to be 63. So 42 calories, 63 calories. So this, why did I calculate 1.5 times IQR? Because that's a number that I'm going to use to figure out where my upper fence and my lower fence are. Okay, so my upper fence, okay, which is my upper threshold, okay, so anything greater than my upper fence is a high outlier. So my upper fence is just, I'm going to go from Q3 and I'm going to go further by 1.5 times IQR. So it's Q3 plus 1.5 times IQR, which is just Q3 we know is 180.5 plus 63. Okay, so that upper fence is at 243.5. My lower fence, I'm going to use the same kind of thinking, and from my Q1, I'm going to go to the left, so I'm going to subtract, so minus 1.5 times IQR. So that is 138.5 minus 63, which gives me 75.5. So there's my lower fence. Okay. So now what I do to draw these fences is I just use dashed lines at their values. So 243.5, so that's 240. So 245 would be right in half, so it's a little less than. So here is my upper fence. So I'm actually going to write UF, and in this case, I'm just going to write UF equals 243.5. You don't have to put that 243.5 because I've shown it the calculation for it here. You could just put UF. Okay, my lower fence is at 75.5, so just a little bit more than halfway. Okay, so my lower fence. Okay, so any values, any actual observations, okay, that are less than 75.5 is going to be considered a low outlier. I don't have any because my min is at 107, my minimum value. So I'm going to go ahead and draw my lower whisker at 107. So that's 100, that's 110, so it's a little more than halfway. So my whisker's right there. Okay, so there's my low whisker. Okay, now I do have a high outlier at 250. So to draw an outlier, I simply make an asterisk. Okay, and then my upper whisker, my high whisker goes to my highest value that is not an outlier. So it goes to there. So if you can see this, my box plot is kind of like this. Okay, so 191 is 200, so that's 190. So 191 is right there. So that is what this box plot should look like.